Okay, assume you've read and worked the problem. This is calculator active again. Part A, you need to know your Syntec cards. It says find at which the speed is 2. Well, speed is the absolute value of velocity. Use your solve command. You end up getting approximately 3.128, 3.473. By the way, if the solve command doesn't work, remember to graph it. Okay, and set your window on 0 to 5 because you need to make sure you have all the answers. Okay. And then find the zeros that way. That is worth 2 points right there. Easy 2 points if you know your Syntec card and know how to use your calculator. Okay, part B, a lot of people know how to kind of get to this, but they kind of mess up their variables. So we need an expression involving an integral that gives the position. Well, I know that if I take the integral, the antiderivative of the velocity, I will get the position. But the thing is they want s of t. So I'm going to put t here. Put 0 here. I cannot use t here. I cannot use the same variable I do up there. So I'm going to use v of x dx. Well, that would give me the position evaluated at t, your b, minus the position evaluated at 0. But remember, s of 0, they tell me, is 10. So if I add 10 to the other side, because it's just an equation, 10 plus that integral, I need v of x. Now, you didn't have to use x. You could have used any variable, but t had to be up there. There we go. Okay. So there's my expression, my integral. That was only, let's see, how much was that? That was only 1 point for that. Okay. But a lot of people knew kind of how to get there, but didn't quite know how to handle those variables. Now it says find the position at t equals 5. So s of 5. Well, 10 plus the integral is 0 to 5. Just plug and chug there. Negative 9.207. Part B was worth 2 points. Okay, part C, find the times which the particle changes direction. Well, this happens. V must change signs. Right? Not only does the velocity have to equal 0, but if it changes direction, it has to change from positive to negative or negative to positive. So this happens, and I just graphed it. I graphed it and looked at it. You can do a number line. It doesn't matter. I just literally graphed V and looked at when it went positive, negative, positive, negative. It's 0.536, 3.318. So all I literally did was graph this on the window, and I used my 0 command. You didn't have to do it that way. You could have done a number line and checked that it changed signs at certain values. So you could use the solve command and then number line. Doesn't really matter. But believe it or not, that was worth 3 points, which I think is pretty significant for that. Okay. Part D, is the speed of the particle increasing or decreasing? Ah, we missed this. I forget which one it was. If it was AP Review 1 or 2, I don't remember. But the fact that a lot of us missed it the first time means hopefully not as many missed it the second time. So part D, if the speed is increasing or decreasing, we need to analyze both the velocity at time 4 and the acceleration at times 4. Okay, now the velocity ends up being a negative number. The acceleration ends up being a negative number. So then we have to explain, since V of 4 and A of 4 have the same sign, it is speeding up. And I shouldn't use it, I should say the particle, but it did use it in the question, so I'm okay there. A lot of people only look at acceleration. That's a big no-no. Remember, same sign speeding up, opposite sign slowing down. That's what we have to show. That was worth 2 points.